Hi, in this video we are going to discuss few questions from the revision worksheet. Starting with the first question here. How is the exponential equation 3 to the power of 4 is equals to 81 correctly written in logarithmic form? So first let's write 3 to the power of 4 is equals to 81. Now this is an exponential equation, and here this 3 is called the base and 4 is the exponent, is called the exponent, and 81 is called the result. So how to convert this exponential equation to a logarithmic form? So first of all, you just write log. When you convert exponential to logarithm, you can first you write log, and then the base of the exponential equation, which is 3, the base of the exponential equation, which is 3, will be the base of the logarithm. And the exponent, or we call it as the power, the exponent or the power will go to the right hand side. And now the result will come alongside with log. The result you can write alongside with log. You can put a bracket for the result as well. So let us check which option gives us the correct answer. So now, yeah, it is the option A. Option A is the correct answer. The right hand side is 4. So here the right hand side is 3. Wrong. In this case, the right hand side is 4. The base is 3, but the base is 81 for the option C. And here the right hand side is not 4. So this is how we do question number 2. This is how we convert exponential function to logarithmic function. Now moving on to the next question here. Rewrite log 5 to 25 to the base 5 is equals to 2. So in this case, we need to convert logarithmic equation to exponential. So first let's write down the question. Log 25 to the base 5 is equals to 2. Now here we are converting logarithm to exponential. To convert logarithm to exponential, you just draw a cross line like this. So it's much more simpler to convert from logarithm to exponential. You just draw a cross line. So 5 is getting connected to 2, which is equal to 25, which is equals to 25. So I repeat, to convert logarithm to exponential, we just have to draw a cross line, and now you can see 5, the base of the logarithm will be the same as the base of the exponential equation or exponential function. Now 5 is getting connected to 2, so that the power here or the exponent will be 2 is equals to 25. Now let's check here, that is option C. And also, to verify whether your answer is correct, in your calculator you just put this left hand side. If you put the left hand side on your calculator, if you are getting the right hand side, that means your answer is correct. This is how we convert logarithm to exponential form. Now moving on to the next one here. Now what is the common difference of the arithmetic sequence? 8, 3, 2, minus 7. So 8, we have 3, and then minus 2, and then minus 7. We say that this is a decreasing sequence. Decreasing sequence means you know that the values keep decreasing. You can see the values are decreasing as we move towards right. That is why we call this as a decreasing sequence. Now, from 8 to get 3, I need to subtract 5. 8 minus 5 is 3. Now, from 3 to get minus 2, I need to again subtract 5. 3 minus 5 is minus 2. Now from minus 2 to get minus 7, I need to subtract 5. So here The common difference is the number that repeatedly we add or subtract to get the next term in an arithmetic sequence. This is an arithmetic sequence. I repeat, the common difference is the number that we repeatedly add or subtract to get the next term, to get the next number. In this case, it is minus 5. Now, that was pretty much simple. Moving on to the next question here. What is the 12th term of the arithmetic sequence? So the sequence is 4, 10, 16, 22, etc. Now, we need to find out the 12th term. To find out the nth term of an arithmetic sequence, we know the formula is a plus n minus 1 into d. Now, since it is mentioned 12th term, your n is 12. And now your first term here, we can clearly see that the first term is represented by the letter A, and the first term is 4. Let us check what the common difference is. 4 plus 6 is 10. 10 plus 6 is 16. 16 plus 6 is 22. So your common difference is 6. To find the 12th term, our duty is just to substitute in this formula. So n is what? N is 12. So A12, which means this is how we represent 12th term, A12. A is 4 plus n. N is 12. 12 minus 1 into d. D is 6. So this will give us 4 plus 12 minus 1 is 11. 11 times 6. That is 4 plus 66, which is 70. 70. So in this case, option B. Option B will be the answer for the 12th term. Now moving on to the next one here. Question number 6. What is the common ratio? So common ratio is for geometric sequence. Geometric sequence. Common ratio. So now here 3 minus 6, 12 minus 24, okay, etc. Now here we need to first of all know the formula for the nth term. Oh, we don't need nth term, it is just common ratio. Common ratio means which number we need to multiply in order to get the next term. We need to find out common ratio means in a geometric sequence. Common ratio means with which number we should multiply in order to get the next term. And you can see here it's alternatively plus, minus, plus, minus. So in this case, the common ratio which we represent by the letter R will be a negative number, Now we can see 3 times negative 2. 3 times negative 2 is negative 6. Negative 6 times negative 2 is 12. 12 times negative 2 is negative 24. So now let's go back to the definition of common ratio. We need to find out the number that gets repeatedly multiplied, the same number that gets repeatedly multiplied to get the next term. So in this case, the number that we keep repeatedly multiplying is minus 2 to get the next term. So common ratio is minus 2. Option B is the answer for that. So we're done with that question as well. Let's move on to the next one. Now find the 5th term of the geometric sequence. 2, 8, 32, etc. Now first of all, we need to know the formula for the nth term for a geometric sequence. It is 8 times r to the power of n minus 1. Now, clearly, A here is the first term. A is the first term. So the first term here is 2. So we got A as 2. Now, moving on to finding out what R is. To find out what R, we need to check with which number we should multiply constantly or repeatedly to get the next term. So we know 2 times 4 is 8. 8 times 4 is 32. Therefore, we are multiplying by 4 to get the next term. So the common ratio is 4 here. And now n. n is n, we will get it from the question. Find the fifth term. So which means n is 5. Now it is just a matter of substituting it into the formula. A n. n is what? 5. This is how we represent fifth term, A5. A5, which is fifth term, is A is 2 times R. R is 4 to the power of n. n is 5. 5 minus 1. So this will give us 2 times 4 to the power of 5 minus 1 is 4. So 4 to the power of 4 is 256. If you put that in your calculator, you will get the answer. 4 to the power of 4 is 256. So 2 times 256, which is 512. So here, in this case, the option is C, 512. So this is pretty much straightforward, simple. You just need to know the formula to find out the nth term of a geometric sequence. A, R, and N are the values that you need to find out. A is the first term. R is the number that we repeatedly multiply to get the next term in this sequence. And N is the number of terms here, fifth term. So N is 5. So now let's move on to the next question here. Solve for x in the exponential equation. 2 to the power of n is equals to 64. Now, we know this is an exponential equation. Exponential equation, how do we convert this into logarithm? So first we will write log. The base of the exponent, that is 2, you will write it as the base of the logarithm. Base of the exponential equation will be the same as the base of the logarithm. The exponent or the power will go to the right. And the result here, 64, you can write it next to log. Now put that in your calculator, log 64 to the base 2. So log, put that in a calculator, 64 to the base 2, you will get it as 6. You will get n as 6. If you are just focusing only on to get the final answer rather than understanding the method here, it's pretty much simple. 2 to the power of, this is called a trial and error method. 2 to the power of 4, instead of n you put 4. Check if you are getting 64. 2 to the power of 4 is 16. So no. 5. Instead of n you substitute 5. 2 to the power of 5. 2 to the power of 5 is 32. It is not 64. Now check 2 to the power of 8. 2 to the power of 8 will be 256. 256. So that is also not 64. Now check 2 to the power of 6. Put it in your calculator. 2 to the power of 6 will give you 64. So you don't have to understand the logic behind the conversion from exponential to logarithm. Just to get the mark, you can uh, do the trial and error method and see which number, when you put, you will get the right hand side. In this case, the right hand side was 64. Now moving on to the next one here, we have solved the logarithmic equation for x. Log to the base 3 x is equals to 4. Now In one of the previous question, I have already explained how to convert logarithm to exponential. We use the cross method. So just draw a cross line. So 3 is getting connected to 4. So 3 to the power of 4 is equal to x. Now 3 to the power of 4 is 81 if you put that in your calculator. So x is equals to 81 will be the final answer. I repeat, log to the base 3 x is equals to 4. We use this cross method to convert logarithm to exponential. Now 3 is getting connected to 4. So 3 to the power of 4 is equal to, the result will be on the right hand side, that is x. 3 to the power of 4, put it in your calculator, you will get it as 81. Now moving on to the next question here. Question number 14 is what we are going to discuss now. So question number 14, I'll just write it here. Solve the logarithmic equation log to the base 2x plus log to the base 2 5 is equals to 4. Now we are going to first solve this left hand side. You can see that both the logarithm has the same base, which is 2. So you can write log to the base 2. And according to the rule or properties of logarithm, if it is plus, you multiply. I will just write the rule here. Log m to the base a plus log n to the base a is nothing but log m times n to the base a. We are going to apply the same rule here. So log x to the base 2 plus log 5 to the base 2 will be log 5x to the base 2 is equals to 4. We just multiplied x with 5. You will get 5x. Now again the same method where we you convert logarithm to exponential. Logarithm to exponential is the cross method. 2 is getting connected to 4. So 2 to the power of 4 is equals to 5x. Now 2 to the power of 4, if you put it in your calculator, you'll see it is 16. 16 is equals to 5x. Now to get the value of x, we divide both the side by 5. So 5 and 5 gets cancelled from both the numerator and denominator. So x will be equal to 16 over 5. If you convert that to decimal, that will be 3.2. 3.2 will be your x. So in order to solve this question number 14, the property that we need to use is log m to the base a plus log n to the base a is equals to log m times n to the base a. And then we just convert log to exponential. And then it's just simple algebra. Now we move on to the next question here. I'll just write down the number 11. That is 3 by x plus 5 by x. Now, this is addition of rational expressions. 3 by x plus 5 by x. If you have the same denominator, you will just write the denominator as it is. 3 by x plus 5 by x. If you have the same denominator, you will write the denominator as it is, same. Now, to get the numerator, you just add both the numerators here. 3 plus 5. 3 plus 5 is 8. 8 over x. Very simple question. This rule is applicable only if we have the same denominator. If you have the same denominator, you just keep the denominator the same and check the sign here. Sign is plus. So you add both the numerators, 3 and 5. 3 plus 5 is 8. Let's move on to question number 12 now. 7 over x plus 1, 7 over x plus 1 minus 2 over x plus 1. So this is also somewhat similar because we have the same denominator. Now, let me just show this. Let me just rewrite this question. Suppose if it was not the same denominator. Let me just take x plus 5. I'm just changing this because we already did one question with the same denominator. You just suppose if we have different denominator. Now, in this case, uh, can check here if this is negative sign and the denominators are different. If the denominators are different, to get the denominator, you multiply both the denominators. X plus 1 times x plus 5. Now, before that, always step number 1 should be, if you have two terms or more than two terms, you put them in a bracket. If you have two terms or more than two terms, put them in a bracket. So here, this is subtraction of rational expressions. This is the method to get the denominator. You just multiply both the denominators. Here the denominators are x plus 1 and x plus 5. So you multiply both of them to get the denominator. Now to get the numerator, we cross multiply. Sometimes we call it as butterfly method as well, but cross multiply. So 7 is getting connected to x plus 5. So 7 gets multiplied with x plus 5. Now minus is the sign, so you put minus. 2 is getting connected to x plus 1. So 2 is getting connected to x plus 1. Now, if you have a bracket and a number outside, we use the distributive property. So distributive property goes like this. The number 7 should be multiplied with all the terms inside the bracket. So 7 times x will give you 7x plus 7 times 5 will give you 35. Now, when it comes here, we need to consider this negative sign as well. So again, we have a bracket and a number outside. We are going to use the same distributive property, but the only thing is you consider the sign minus. Minus 2 has to be multiplied with all the terms inside the bracket. So minus 2 will be multiplied by x and minus 2 will be multiplied by 1. Minus 2 when you multiply by x, you will get minus 2x. Minus 2 when you multiply by 1, you will get minus 2 divided by x plus 1 into x plus 5. X plus 1 into x plus 5, we can use the FOIL method. So FOIL method, first, outer, inner, last. The first term from both the bracket, that is x times x, will give you x square. Now O represents outer. The outer terms from both the bracket are x and 5. So x, when you multiply by 5, you will get 5x. Now the I represents inner. Inner terms from both the brackets are 1 and x. 1 multiplied by x is 1x. And now L represents last. The last term from both the bracket is 1 and 5. Positive 1 times positive 5 is positive 5. Now it is just the collection of like terms. Like terms means the ones with the same variable. Variables are the alphabets or the letters. So 7x and minus 2x. They both are like terms. 7x minus 2x is 5x. 35 minus 2. They both are like, the numbers are like terms. 35 minus 2 is 33. Divide by. Whenever we do FOIL method, the middle two terms are always like terms. So this will give you x square plus 5x plus 1x. They both are like terms because they have the same variable. 5x plus 1x is 6x plus 5. This is the final answer for question number 12. So it is just subtraction of rational expressions. The only thing that you need to know is to get the denominator, you multiply both the denominators. To get the numerator, you cross multiply. This method is applicable if you have different denominators. In the previous example, we already studied how to solve when we have the same denominators. And then additionally, we did FOIL method. You will see FOIL method again as well in the next two questions. So let's quickly move on to question number 4 here. X plus 2 over x plus 3 is equal to x minus 1 over x plus 1. Now this question is from solving rational equations. The methods are going to be the same only. Step number 1, if you have two terms or more than two terms, put them in brackets. Now, the thing that you need to know is, in mathematics, if you have two fractions and in between equal to sign, if you have two fractions, that is, a fraction means it has a numerator and a denominator. So here you have one fraction, here you have another fraction. So if you have two fractions and in between equal to sign, the method that we use is cross multiplication again. So x plus 2 is getting connected to x plus 1. So x plus 2, you multiply that with x plus 1, equal to sign, you put the equal to sign. Now x minus 1 is getting connected to x plus 3. So x minus 1 multiplied by x plus 3. Now we are going to use FOIL method 2 times on both the sides. Let's first let's take the left hand side here and we do the FOIL method. First term from both the brackets, x and x times x is x squared. The outer terms from both the bracket, x and positive 1, x times 1 is 1x. Now the inner terms, positive 2 times x is positive 2x. And now the last terms from both the bracket is 2 and 1. Positive 2 times positive 1 is positive 2 is equal to. Now let's do the FOIL method for the right hand side. First term from both the bracket, x and x will give you x square. Now the outer terms, x and positive 3. X times positive 3 is positive 3x. Now the inner terms, minus 1 and x. Minus 1 times x is minus 1x. Now the last term from both the brackets, minus 1 and positive 3. Minus 1 times 3 is minus 3. Now, do you remember in the previous question I told you, whenever we do FOIL method, the middle two terms are always like terms. The middle two terms are always like terms. So our equation will become x square. 1x plus 2x is 3x plus 2 is equal to x square. 3x minus 1x. 3x minus 1x is 2x minus 3. If you have same things on both the sides, you can cancel them, or else I'll not. Okay, yeah. So if you want, you can take everything to the left hand side. So x square plus 3x plus 2. Bring everything to the left hand side. Positive x square will become minus x square. Positive 2x, when you change the side, it will become minus 2x. Minus 3, when you change the side, it will become positive 3. Now there is nothing on the right hand side, so it becomes 0. What I did here is I took everything from the right hand side, we took it to the left hand side. By doing so, we need to change the signs. So x square and minus x square gets cancelled. 3x minus 2x. 3x minus 2x is 1x. 3 minus 2 is 1, so 1x. Positive 2 plus 3 is positive 5 is equal to 0. 1x can also be written as x. Positive 5, you take it to the right hand side, it becomes negative 5. So x is equals to minus 5 will be your answer. I repeat, so this is from the topic solving rational equations. When we have uh, two fractions and in between equal to sign, we cross multiply, you do the FOIL method, and then you bring everything to the left hand side, get the value for x. Simple as that. Now we have one more question here, which is somewhat similar, much more easier. The next question. Question number 2 here. I'll just try the question number 2. 3 over x plus 1 is equals to 2 over x minus 2. Now, as we know, step number 1 is always, if you have two terms or more than two terms, put them in a bracket. Now, we have two fractions, and in between equal to sign, we do the cross multiplication. Now 3 is getting connected to x minus 2 and 2 is getting connected to x plus 1. And what did we study? If you have a bracket and a number outside, distributive property. 3 should be multiplied with all the terms inside the bracket. 2 should be multiplied with all the terms inside the bracket. Now 3 times x is 3x minus 3 times 2 is 6 is equal to 2 times x is 2x. 2 times 1 is 2. Bring all the variables on one side and numbers on the other side. 3x, 2x. Bring this 2x to the left hand side. So 3x, positive 2x goes to the left hand side, it becomes a negative 2x is equals to 2. Now negative 6, you bring it to the right hand side. Negative 6, when it goes to the right hand side, it becomes positive 6. Now we have all the variables on one side, all the numbers on the other side. 3x minus 2x is 1x, or you can simply write x. 2 plus 6 is 8. So x is equals to 8 will be your final answer. So this is much more easier than the previous question. The method, although being the same, to get the, if you have two fractions and in between equal to sign, you do the cross multiplication, distributive property, bringing all the variables on one side, numbers on the other side. Now moving on to the arithmetic series, question number 5 here. Now for question number 5, evaluate the arithmetic series sigma k is equals to 1 to 20, 2k plus 5. Now to find, let's just first write down the formula, since they're asking us to find out the total sum. To find the sum of n terms, the formula is n into a plus l divided by 2, where n is the number of terms, a is the first term, and l is the last term. Now we have a formula to find out what n is. N is upper limit minus lower limit plus 1. Now, first of all, this is our question. Let's identify the values. K is equals to 1 to 20. So the number below bottom is the lower limit. So the lower limit is 1. The number above is the upper limit. So the upper limit here is 20. So lower limit is 1, upper limit is 20. To get the value for n, we know the formula. Upper limit is 20 minus lower limit is 1 plus 1. So 20 minus 1 is 19, 19 plus 1 is 20. So we got n. So we found out what n is. Let's now find out what a is. How do we find out a? First, what is inside the bracket? Inside the bracket it is 2k plus 5. Now, to get the a, which is the first term, what you have to do is whatever this inside the bracket, you just write that 2k plus 5. Now, instead of the variable k, you replace that k or you substitute that k with the lower limit. Lower limit here is 1. So instead of this k, you replace that k with 1. The lower limit, always the lower limit. Now 2 times 1 is 2 plus 5, which is 7. So now you have your first term as well. First term is 7. I repeat, whatever inside the bracket, you just write it 2k plus 5. And instead of the variable k, you substitute it with the lower limit. Now, to get the last term L here, to get the last term L, again the same thing. Whatever inside the bracket, you just write it 2k plus 5. And instead of the variable k, this time to get the last term, you substitute it with the upper limit, the number at the top. Instead of k, you substitute it with the upper limit, the number at the top. So 2 times k here, the upper limit is 20 plus 5. Now 2 times 20 is 40. 40 plus 5 is 45. Now we have the L as well. Now just put everything in this formula. N is S20. S20 is equal to N is 20 times A is the first term 7 plus L is the last term which is 45 divided by 2. So put the whole thing in your calculator. 20 times 7 plus 45 divided by 2, which will give you 520. 520 will be the final answer. So in this case, what we did here is, first of all, from the question, you identify what is the lower limit and upper limit, and then you find out what n is using this formula. And we need the first term and the last term. To get the first term, you substitute for k in this bracket, and substitute for k, 1, substitute for k 1, you will get the first term. Now in the for the last term here, what we need to do is, instead of k, you substitute it as the upper limit. Upper limit here in this case is 20. Then you substitute the whole thing in the calculator. Still you will get the final answer, which is 520. Moving on to the next question here. which is evaluate the geometric series sigma k is equals to 1 to 6, 4 times 3 to the power of k minus 1. Now this is how it looks when it comes to a geometric series. You have sigma, the lower limit 1. So you can just write here lower limit is 1, upper limit is 6. Now, first of all, before moving forward, you need to uh, study the formula. You need to know the formula. Sum of n terms is a times 1 minus r to the power of n divided by 1 minus r. So we need a, we need r, and we need n. First of all, we know the lower limit we know 1, the upper limit we know 6. So first we can find out this n using the same formula as before. Upper limit minus lower limit plus 1. So upper limit in this case is 6 minus lower limit in this case is 1 plus 1. So 6 minus 1 is 5, 5 plus 1 is 6. So we got the n value. Now we can find out what r is. R will be always inside the bracket that is connecting to k minus 1, the power k minus 1. So r will be the number that is inside the bracket which is connecting to k minus 1. So in this case, r is 3. R is 3. Now we need a. So for a, what we need to do is just write here whatever we have, 4 times 3 to the power of k minus 1. Whatever we have here, you just write. In order to find out a, you just write that 4 bracket 3 to the power of k minus 1. Now instead of k, you need to substitute the lower limit always. Instead of k, you need to substitute the lower limit to get a. So this will become 4 times 3 to the power of, instead of k, we will be substituting it with the lower limit, which is 1. 1 minus 1 is 0. So 4 times 3 to the power of 0. Anything to the power of 0 is 1. You can directly put this in your calculator, or else you need to know that any number x to the power of 0 is 1. 100 to the power of 0 is 1. 1000 to the power of 0 is 1. Or 2500 to the power of 0 is 1. So here 3 to the power of 0 is 1. So 4 times 1 is 4. Now we have everything. We have n, we have r, we have a. N is pretty much the same thing as we did in the previous question to find out n. Upper limit minus lower limit plus 1. R will be the number in the bracket that is getting connected to k minus 1. The number which has the power k minus 1. That will be your R. A, just whatever given, you write it here, 4 times 3 to the power of k minus 1. Now instead of the variable k, always substitute with the lower limit. Lower limit is 1. And put that in your calculator, you will get the a value. Now sum of n is 6 is equals to a. A is, what did we get? 4 into 1 minus r. R was 3 to the power of n is what? N is 6 divided by 1 minus r is 3. Let's put the whole thing in our calculator. I'm going to directly put the whole thing in our calculator. 4 times 1 minus 3 to the power of 6 divided by 1 minus 3, which will give us 1456. This is how we find out the sum of n terms in a geometric series. It's not that hard, just need to know this formula here. And if you know this formula, then we need A, we need R, we need N. R is straightforward from the question. One inside the bracket, that is having the power as k minus 1, will be R, and N, use the formula upper limit minus lower limit plus 1, and what else? A. Just whatever the question given, you write once again, but instead of the variable k, you replace it with the lower limit. Now let's move on to the next question here. 4, this is from the topic solving exponential equations. 4 to the power of 2x minus 1 is equals to 4 to the power of 3. Now, if you have the same base, so here this is the base 4, this is the base 4. If you have the same base on both the sides, you can just cancel the bases and you can equate the powers. That is, equate the powers means 2x minus 1. You equate, put an equal to sign, write 3. Now minus 1, bring it to the other side. So 2x is equals to 3 plus 1. 3 plus 1 is what? 3 plus 1 is 4. In order to find out x, you divide both the side by 2. 2 and 2 gets cancelled. X is equals to 4 divided by 2, which is 2. That is the final answer for question number 2 here. 4 to the power of 2x minus 1 is equals to 4 to the power of 3. If you have the same base, you cancel the base and then equate the powers. 2x minus 1 is equal to 3. Minus 1, all the variables should be on one side and all the numbers should be on the other side. So minus 1 is a number, should take it to the right hand side, it becomes positive 1. So 2x is equals to 3 plus 1, which is 4. Now we need to find out what x is. So to remove that 2, which comes along with x, you divide both the side by 2. We'll get x is equals to 4 by 2, which is 2. Let's move on to the next question here. 6 to the power of 3x is equals to 6 to the power of 15. Again, the same rule. If you have the same base, you can cancel the base and equate the powers. We need only x. So to remove this 3, we divide both the side by 3. 3 and 3 gets cancelled. X is equals to 15 divided by 3, which is 5. Not that difficult, very simple one. We're done with question number 3. Now moving on to the next question. 7 to the power of x minus 1 is equals to 4. Now, this is also solving exponential equation. Exponential equation should always be in the form of a to the power of x is equals to y. In this form we need. In order to make it in this form, what we can do? Bring this minus 1. We know the numbers, all the numbers should be on one side. So 7 to the power of x is equals to minus 1 goes to the other side. It becomes positive 1. 4 plus 1. 4 plus 1 is 5. So now this is in the same format. 7 to the power of x is equals to 5. This is an exponential equation. How do we convert it into logarithm? You write log first. The base of the exponential equation will be the base of the logarithm. The power, the exponent, will move to the right hand side, and the result 5 will come along with log. So let's put the left hand side in our calculator. Log to the base 7 and log 5 to the base 7, which will give us 0.827. 0.827 will be the answer for question number 2, this one. Now, let's quickly move on to the next question here. Let's check how many questions more we have. Okay, so we have the next question here. 5 times 3 to the power of x minus 7 is equals to 43. Now we know this is again solving exponential equation. Exponential equations should be in the form of a to the power of x is equals to y. So let's bring this, all the numbers should be on one side. So minus 7, you bring it to the other side. So 5 times 3 to the power of x is equals to 43. Minus 7 will become positive 7. So 5 times 3 to the power of x is equals to 43 plus 7 is 50. Now we need to remove this 5. To remove that 5, you divide both the side by 5. 5 and 5 gets cancelled. 3 to the power of x is equals to 50 divided by 5 is 10. Now, this is the standard form of an exponential equation. Once we reach there, you convert the exponential equation to logarithm. So first you write log. The base of the exponential will be the base of the logarithm. The power will move to the right hand side. The result will come next to log. Put that in our calculator. Log 10 to the base 3. Log 10 to the base 3 is, when you put that in your calculator, you will get 2.096 approximately. 2.096. So the main idea when you solve exponential equation is make the equation in this standard form. In this standard form, it will be much more easier. Okay, now moving on to the next question here. Logarithm, log to the base 8, 7x minus 5 is equals to log to the base 8, 4x plus 9. Check both the side, we have log with the same base. So you cancel them. Both the side you have the log with the same base. Now 7x minus 5 is equal to 4x plus 9. We know that the variables, the alphabets, the letters should be on one side and the numbers should be on the other side. So 7x, this variable 4x, positive 4x, when it goes to the left hand side, it becomes negative 4x. All the numbers on the right hand side, we have 9. And this minus 5, if you bring it, it will become positive 5. 7x minus 4x is 3x is equals to 9 plus 5 is 14. We need x. To remove this 3, we divide by 3 on both the sides. 3 and 3 gets cancelled. X is equals to 14 divided by 3. When you put it in your calculator and change it into decimal, you'll get 4.67. That will be the final answer. So if you have log with the same base on both the side, and in between an equal to sign, you can cancel them and you do the basic algebra. Bring all the variables on one side, bring all the numbers to the other side. Now, The next question. The first term of an arithmetic sequence is given as 7 and the common difference is given as 5. Find the 8th term. So n is 8 in this case. We know to find the nth term of an arithmetic series, the formula is a plus n minus 1 into d. So the first term represented by the letter a is given as 7. The common difference represented by the letter d is given as 5. And the nth term, the number of terms, is given as 8. Simple. Substitute here. A instead of n, 8. The first term is 7 plus n is 8 minus 1 times d is 5. So 7 plus 8 minus 1 is 7 times 5. 7 times 5 is 35. 35 plus 7 is 42. That is the final answer. Simple as that. So just need to know this formula to find the nth term of an arithmetic sequence. Formula is this, and the first term and the common difference and the number of terms was given in the question. Substitute and get the answer. That's all. Now, the last question in this worksheet. The first term of an geometric sequence is 3. The common ratio is given as 2. Find the 10th term. So n is 10. Same like previous, but this is geometric sequence. You know the formula, nth term is a times r to the power of n minus 1. So a, n is 10, so 10th term. This is how we represent 10th term. A is 3 times r is 2 to the power of n minus 1. n minus 1, n is 10. So 10 minus 1. So 3 times 2 to the power of 9. Put that in our calculator. 3 times 2 to the power of 9. You will get it as 1536. This is the final answer. So we covered almost all the different variety questions that will be in this particular worksheet from the topics exponential and logarithm, solving exponential equation, solving logarithmic equation, operations, that is addition, subtraction, multiplication and division of rational expression, then solving rational equations, finally arithmetic and geometric sequences. And if you have any doubt, feel free to write it in the chat box. Thank you for watching.